students, welcome to Sunil's tutorial. I'm Sunil Nirvani and today we'll be doing this chapter called as ionic equilibria. Let's see this. Let's do the numericals of solubility product. Take down solubility of silver bromide. Take down solubility of silver bromide is 1.28 into 10 raised to minus 5 moles per decimeter cube. Solubility of silver bromide is 1.28 into 10 raised to minus 5 moles per decimeter cube at 298 Kelvin. Calculate the solubility product of silver bromide. Calculate the solubility product of silver bromide. Now, silver bromide is a sparingly soluble salt, right, which dissociates as silver bromide will dissociate reversibly to give you silver ions plus bromine ions solubility. Let's assume that the solubility of silver bromide is S. Therefore, the solubility of silver will be S and bromine will also be S. Solubility product is given as active mass of silver ions into active mass of bromide ions, right? So in that case I can say solubility product is going to be S into S, which is S square. You already know the value of S. You can substitute and get this answer. The answer for this should be 1.6384 into 10 raised to minus 10. Take down next one please. The solubility of lead sulfate is 3.03 into 10 raised to minus 5 kgs per decimeter cube. Calculate the solubility product. The solubility of lead sulfate is 3.03 into 10 raised to minus 5 kgs per decimeter cube. Calculate the solubility product. If the molecular weight of lead sulfate, calculate the solubility product if the molecular weight of lead sulfate is 303. Now here the problem is, guys, they've given you solubility in terms of kgs per decimeter cube. You have to first convert it into moles per decimeter cube. How do I convert this? I can say that solubility in moles per decimeter cube is nothing but solubility in kgs per decimeter cube divided by molecular weight. So solubility in kgs per decimeter cube is 3.03 into 10 raised to minus 5. Molecular weight is always, when given, assumed in gram. Convert that into kilograms. So this is 303 into 10 raised to minus 3. So when you solve this, you will get your solubility in terms of moles per decimeter cube. Once you have this, then I can say that lead sulfate is a sparingly soluble salt which dissociates as PbSO4. Valency of lead is 2. So Pb plus plus. Valency of sulfate is minus 2. Solubility. If this is S, then this will, and this will also be S. So I can say that solubility product is nothing but active mass of lead into active mass of sulfate. So this is going to be nothing but S into S, which is S square. You would have found out the value of S from here. You've already found out the value of S, so you should get this answer as substitute. You should get this answer as 1 into 10 raised to minus 8. Right? Take our next one, please. The solubility product of silver bromide. The solubility product of silver bromide is 3.3 into 10 raised to minus 12 at 298 Kelvin. At 298 Kelvin.
Solubility product of silver.
The solubility product of silver bromide is 3.3 into 10 raised to minus 12 at 298 Kelvin. What concentration of bromide ions? What concentration of bromide ions? What concentration of bromide ions is needed to precipitate? What concentration of bromide ions is needed to precipitate silver bromide from a solution of 0.01 molar silver. Now, I can say that silver bromide is a sparingly soluble salt which dissociates as silver bromide dissociates to give you Ag plus Br minus solubility. If the solubility of silver bromide is S, then solubility of silver will be S and bromine will also be S. Now, solubility product is active mass of silver into active mass of bromine. Solubility product is given to you as 3.3 into 10 raised to minus 12. Active mass of silver is given to you as 0.01 into bromine. Right? Simplify this, you will get your answer. You will get the answer for this as active mass of bromide should be 3.3 into 10 raised to minus 10 moles per decimeter cube. Now, if you want a precipitate, that means the concentration of bromide should be more than this. So the final answer you will write is hence bromide ion should be greater than 3.3 into 10 raised to minus 10 moles per decimeter cube for precipitate to be formed. Right? Next, take on next one, please. The solubility of lead sulfate. The solubility of lead sulfate is 1.01 into 10 raised to minus 4 moles per decimeter cube. Calculate its solubility product. Calculate its solubility product. I can say that lead sulfate is a sparingly soluble salt which dissociates as follows. As follows: lead sulfate PbSO4 will dissociate reversibly to give you Pb++ plus SO4 minus solubility. Let's assume solubility of lead sulfate as S. So solubility of lead and sulfate ions both will be S and S. We know that solubility product is nothing but active mass of lead into active mass of sulfate ions, right? So in that case you will get this as KSP. I can say that therefore KSP is S into S, which is S square. You already know the value of S, you can substitute and get this answer. The answer for this should be 1.0201 into 10 raised to minus 8. Next, take our next one please. The solubility product of lead sulfide, the solubility product of lead sulfide is 4.2 into 10 raised to minus 28. 4.2 into 10 raised to minus 28 at 300 Kelvin. At 300 Kelvin, what sulfide ion concentration? What sulfide ion concentration is required to precipitate? What sulfide ion concentration is required to precipitate lead sulfide from a solution containing? What sulfide ion concentration is required to precipitate lead sulfide from a solution containing 0.001 molar lead ions? Now, I can say that lead sulfide is a sparingly soluble salt which dissociates as follows. I can say that PbS will dissociate reversibly to give you Pb++ plus S minus 2. Solubility is S, so this will be S and this will also be S. So I can therefore say that solubility product KSP will be Pb++ into S2 minus, right? You know the solubility product, you know the active mass of lead, so you should get the active mass of sulfate ions. The answer for this sum should be active mass of sulfate ions should be equal to 4.2 into 10 raised to minus 25 moles per decimeter cube. But you want a precipitate, so you will say hence sulfate 2 minus should be greater than 4.2 into 10 raised to minus 25 moles per decimeter cube, right? That is the sulfide ion concentration required. Next, take on next one please. The solubility product of silver iodide, the solubility product of silver iodide is 1.56 into 10 raised to minus 16 at 298 Kelvin. What concentration of iodine? What concentration of iodine is required? What concentration of iodine is required to precipitate? What concentration of iodine is required to precipitate silver iodide from a solution of 0.01 molar silver, from a solution of 0.01 molar silver nitrate solution, from a solution of 0.01 molar silver nitrate solution. Same thing like the previous sum. Silver iodide is a sparingly soluble salt which dissociates as AgI, will dissociate reversibly to give you Ag plus plus I minus, right? In which case I can say that solubility, if this is S, then this will be S and this will also be S. Then I can say that Ksp is silver ions into iodine ions, right? You have Ksp, you know the solubility of silver ions, so you should get the solubility of iodine ions. You should get this answer as iodine ions should be equal to 1.56 into 10 raised to minus 14 moles per decimeter cube, right? You will say hence iodine ion concentration should be greater, since I want to precipitate, greater than 1.56 into 10 raised to minus 14 moles per decimeter cube, right? Next, take the next one please. I'll give you sums for practice. The solubility product of lead sulfate, is 1.02 into 10 raised to minus 8 moles per decimeter cube. Calculate the solubility of lead sulfate. Calculate the solubility of lead sulfate. Lead sulfate is a sparingly soluble salt which dissociates as follows. PbSO4 will dissociate reversibly to give you Pb plus 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 SO4 minus minus. Solubility, if this is S, then this and this will also be S. So I can therefore say that Ksp is active mass of Pb plus plus into active mass of sulfate minus minus. So I can therefore say that Ksp is S into S. Ksp is S square. Therefore I can say S is square root of Ksp. Should get your answer. Solubility. The answer for this should come out to 1.01 into 10 raised to minus 4 moles per decimeter cube. Next, take the next one please. Derive a relationship between, I taught you this before, we'll do some numericals on that. Derive a relationship between solubility and solubility product. Derive a relationship between solubility and solubility product for the following salts. For the following salt. First, aluminium sulfate, Al2SO4 3. Right? Now I'll show you one and then I'll give you the remaining for practice. We know that aluminium sulfate dissociates reversibly to give you valency. It will give you 2 aluminium, valency of aluminium is +3, plus 3 sulfate, 2 aluminium, 3 sulfate, valency is -2, right? Valency of sulfate will be this, valency of aluminium will be this. This will be the number of aluminium ions, this will be the number of sulfate ions, right? Solubility. If the solubility is S here, then this will be 2S and this will be 3S. Ksp is nothing but atom mass of aluminium, the whole square, plus because there are 2 molecules, and sulfate ions, the whole cube. So this is going to be 2S the whole square into 3S the whole cube. This is 4S square into 27S cube. So the solubility product will be 108S5. So the solubility product of the salt Al2SO4 3 will be 108S5. Right? Now I'm going to give you a few sums like this for practice. Right? Take on the next one, please. You have to derive relationship between solubility and solubility product for these salts. First is AgCl, next Ca3PO4 twice, aluminium chloride, barium chloride. Right? So these 4 sums you should be able to do on your own. Right? Now that we finished solubility, let's move on to the next product, terminology, which is hydrolysis. Right? What do we understand by hydrolysis? How do I define hydrolysis? It is a reaction in which cations from salt react with hydroxyl of water, or anions from acid, anions of salt react with hydrogen ions of water to form a basic solution. Right? React with water to produce either an acidic or a basic solution. Okay, I'll write the definition down and explain it to you. The reaction definition. The reaction in which either cations of salt react with hydroxyl ions of water, or anions of salt react with hydrogen ions of water, or both ions of salt react with water to produce an acidic or basic solution is called hydrolysis. Right? So that is what is hydrolysis. What in simple language I can say hydrolysis is nothing but it is the reverse of neutralization. I can say that it is reverse of neutralization. Hydrolysis is the reverse of neutralization. Let us assume that let Ba be a salt that is dissolved in water. Ba is a salt that is dissolved in water. It undergoes hydrolysis. It undergoes hydrolysis as follows. Ba is my salt which is going to react with water to give you hydrolysis. Right? In that case, B will react with OH and BOH plus HA. Right? This is salt, this is base, and this is acid. The reverse reaction would have been neutralization. So in simple language, you have a reaction where the salt reacts with water to give you an acid and a base. Right? Let's try to write this in ionic form. The ionic equation salt dissociates to give you B plus plus A minus. Water as it is will give you BOH plus HA. Right? That is what is hydrolysis. Hydrolysis depends upon hydrolysis is when the salt reacts with water to give you an acid and a base. Fine, do we get this thing here? Now, depending upon the strength of the acid and the base that is formed, the reaction may have either excess hydrogen ions or it may have excess hydroxyl ions. Depending on the strength of acid and base formed, the solution may have either excess H plus ions or excess OH minus ions. Right, do we get this thing here? Now depending upon what kind of salt you are using, you will get either an acidic solution or you will get a basic solution. Let's see what are the different types of salt that you can have. Let's see the types of salt. Now on the basis of nature of acid and the bases from which the salt is obtained, you have 4 different types of classification of salts. On the basis of the nature of acid and bases, nature of acid and bases from which the salt is obtained, there are 4 types of salts. The first is salt of a strong acid and a strong base. Salt of strong acid and strong base. Second, salt of strong acid and weak base. Next, salt of weak acid and strong base. And last, salt of weak acid and weak base. Salt of weak acid and weak base. So these are the 4 different types of salts that you can get. Right? Do you get this in here? So depending upon the nature of the acid and the base used, you will have 4 different types of salts that you will get. Fine, do we get this in here? Okay, let's see how these salts affect the reaction. Let us see a hydrolysis reaction of a strong acid and a strong base. Hydrolysis of a strong acid and strong base. Right? Now, a strong acid and strong base, a salt of a strong acid and strong base does not undergo hydrolysis. Let's see this. Let's consider NaCl is a salt of strong acid and strong base. Right? Strong acid will be HCl and strong base will be sodium hydroxide. Right? So I can say NaCl is a salt of strong acid and strong base. Right? Now, if it reacts with water, it reacts with water. That means NaCl dissolved in water will give you reversibly the strong acid and strong base. It will give you NaOH plus HCl. Right? Now, ionic reaction. The salt will dissociate to form Na plus plus Cl minus. Water is present in excess quantity, right? Therefore, its dissociation will be constant, right? Since I have a strong base will dissociate completely to give you Na plus OH minus. Strong acid will again dissociate completely to give you H plus Cl minus. Na plus gets cancelled, Cl minus gets cancelled. That leaves me with H2O, gives you H plus OH minus. You will get H2O will reversibly give you H plus OH minus. Neither do I have in this reaction, neither cations nor anions of the salt are added to water. Hence, the solution has equal concentration of hydrogen and hydroxyl ions. The pH of this solution will be 7, and hence we say that salt of a strong acid and strong base does not undergo hydrolysis. Just write that down. In the net reaction, neither cations nor anions of the salt are present. React with water. Neither do you have anions nor do you have cations. The solution has equal concentration. The solution has equal concentration of hydrogen and hydroxyl ions. Right? Therefore, this is a neutral solution having pH 7. This is a neutral solution having pH 7, right? Once I have this, hence I can say that salt of strong acid and strong base does not undergo hydrolysis. Therefore, salt of strong acid and strong base does not undergo hydrolysis. Right? Next, let us see. We saw salt of strong acid and strong base. Let us see salt of strong acid and weak base. Salt of strong acid and weak base. Let us consider salt of strong acid and weak base. Now, let's consider copper sulfate. Copper sulfate is a salt of strong acid and weak base. CuSO4 is a salt of strong acid and weak base. It undergoes hydrolysis as follows. Right, it undergoes hydrolysis as follows, where you will have copper sulfate reacting with water, CuSO4 reacts with water reversibly to give you copper hydroxide, CuOH twice plus H2SO4 sulfuric acid, right? So in this case you have weak base and here you have strong acid, right? Now let's write this reaction in ionic form. In ionic form, Cu plus SO4 minus. First of all, the previous reaction I don't think is balanced because you have 4 hydrogens. So 2 here, right? So in that case you will have Cu plus 2 SO4 minus plus water present in excess quantity. It dissociates to a very small extent, hence its dissociation is almost constant. When we saw ionic product of water we had seen this, right? Since this is weak base, this will not dissociate, plus strong acid will give you 2H plus SO4 minus, right? The weak base will not dissociate, the strong acid will dissociate. Now cancel the like terms, sulfate ions get cancelled, so you will get Cu2 plus water. This is my net reaction, will reversibly give you CuOH twice plus twice hydrogen ions. Now if you see the right hand side of my net reaction, what I see is that you have hydrogen ions present in it, right? In the net reaction you see that cations of the salt react with water. In the net reaction cations of the salt react with water, right? Copper is reacting with water, right? Therefore the salt is hydrolyzed. The salt is hydrolyzed, right? Once the salt is hydrolyzed, I can also say that the solution contains excess hydrogen ions. The solution contains excess H plus ions, right? Since the solution contains excess H plus ions, therefore I can say that the salt solution is acidic in nature. Therefore the salt solution is acidic in nature and has pH acidic in nature less than 7, right? So thus this is how you have hydrolysis of a salt of strong acid and weak base. Next, let us see salt of weak acid and strong base. Let's see hydrolysis of a salt of weak acid and strong base. Let's consider, I want weak acid and strong base, so let's consider the salt sodium carbonate, right? Let's consider, I can say that sodium carbonate is a salt of weak acid and strong base. It is a salt of weak acid and strong base. It reacts with water as follows. It reacts with water as follows. Sodium carbonate, Na2CO3, reacts with water to give you carbonic acid H2CO3 plus sodium carbonate, sodium hydroxide. Right? This is your weak acid. This is strong base. Right? Reaction is not balanced. I have H2 here. H is 2 here and H is 3 here. So I can put 2 here. Sodium is 2. So put 2 here. So sodium hydroxide you will get. Okay, now the reaction is balanced. Right? 3 oxygen is 3 and 2 5. Yeah, all of them are balanced. I can say that the ionic reaction sodium carbonate will split to give you 2 sodium ions plus carbonate has valency of -2 plus water in excess quantity. Water, its dissociation, pure water dissociates to a very small extent and hence its dissociation can be considered as constant. Weak acid will not dissociate. Plus strong base will give you 2Na plus 2OH minus, cancelling out the like terms. 2Na plus 2Na plus gets cancelled. Therefore the net reaction will be carbonate ions plus water gives you reversibly carbonic acid plus twice OH minus. Right? Now in this reaction you see that the anions of salt are reacting with water and therefore the salt gets hydrolyzed. The anions of salt react with water. Anions of salt react with water and hence salt is hydrolyzed. Right? Now, if you see the solution has got excess OH ions. The solution contains excess OH minus ions. Hence, the solution is basic and its pH is greater than 7. Right? So this is your hydrolysis of salt of weak acid and strong base. Next, let's try to see hydrolysis of salt of weak acid and weak base. Next, let's see hydrolysis of salt of weak acid and weak base. Hydrolysis of salt of weak acid and weak base. Now let's consider, say, ammonium acetate. Ammonium acetate is a salt of weak acid and weak base. Right? It reacts with water as follows. It reacts with water as follows. So in which case I can therefore say that ammonium acetate CH3CONH4 reacts with water to give you acetic acid, that is CH3COH plus ammonium hydroxide NH4OH. This is your weak acid and this is your weak base. Right? Now the ionic reaction can be written as follows. The ionic reaction is salt dissociates, so CH3COO negative plus NH4 positive plus water dissociates reversibly. Weak acid will not dissociate, so your acetic acid will not dissociate. Plus weak base, ammonium hydroxide, will also not dissociate. Right? So my net reaction will have both cations and anions of salt react with water, and that's how the salt has been hydrolyzed. I can say here, see, here you have anions are getting hydrolyzed, similarly cations are also getting hydrolyzed, right? So I can say in thus both cations and anions of salt react with water. Anions and cations of salt both react with water, and the salt gets hydrolyzed, and salt is hydrolyzed, right? Once I get that the salt is hydrolyzed, now in this reaction on the product side you neither have positively charged hydrogen ions nor do you have negatively charged hydroxyl ions. Therefore, I can say the in net reaction neither hydrogen nor hydroxyl ions are produced. Neither are hydrogen ions produced nor are hydroxyl ions produced, right? So thus this is a neutral solution. Fine, do we get this thing here? So do we understand the hydrolysis? Now once I have hydrolysis, then I can say that what do we understand by degree of hydrolysis? Degree of hydrolysis. What is degree of hydrolysis? Degree of hydrolysis. Now, degree of hydrolysis is the fraction of the total number of moles of the salt that have undergone hydrolysis at equilibrium. Suppose if I put 100 molecules of salt, out of which 40 react with water to form either acid or base, right? In that case, that fraction that has been hydrolyzed to the total number of molecules that were present in the solution is called as degree of hydrolysis. Degree of hydrolysis is represented by the letter H, right? So degree of hydrolysis definition, the fraction of the total number of moles, the fraction of the total number of moles of the salt which have undergone hydrolysis at equilibrium and at a given temperature is known as degree of hydrolysis. Right? That is what is degree of hydrolysis. It is represented by H. Mathematically, H is given by the formula number of moles hydrolyzed at equilibrium to total number of moles present. H is equal to number of moles hydrolyzed at equilibrium to total number of moles present. That is what is your degree of hydrolysis. Fine, do we get this thing here? Next, what do we understand by hydrolysis constant? Right? Now, hydrolysis constant is the equilibrium constant which is obtained by applying law of mass action to hydrolysis reaction. What is hydrolysis constant? It is the equilibrium constant. Equilibrium constant obtained by applying law of mass action. Applying law of mass action to hydrolysis reaction of salt. Reaction of salt. Right, that is what is hydrolysis constant. Okay, we will stop this here for today. Thank you very much.